Hello class, so your project proposal is due tomorrow. So tomorrow, you're actually going to turn in your project proposal. At the end of class. In case you're not sure. So be ready for that. If you don't think you can, and you're not going to have the whole period to work on it. We're going to start doing data collection, and we are going to start doing other work to keep up your math skills in this class. So you're not really going to have a lot of time to work on it. So do work on it tonight. Alright, remember your entire project is worth 150. This is worth 10, which isn't a huge part of it, I know. However, as time goes on, these tiny points that you're missing out on are really going to add up in the end. So try to get these. These are the easy points. As far as what it should look like after you turn it in, I'm going to refer back. Now, it doesn't have to look like this, but you're going to increase your likelihood of getting it right if you do have 3 paragraphs, where it has your first goal in your own words, the second paragraph would be your second goal, the third paragraph would be your first. So the first goal, it should, right? So the first goal is you have to, essentially what you're looking for is you need to graph acceleration versus mass. So you have to find acceleration and mass. To do that, you must measure what things. Hopefully you must measure mass. Write what you're going to measure with. Hopefully it's a scale. Then you have to also measure distance in time. Why do you have to measure distance in time? Because you have to find acceleration, and you must therefore use this formula. So I'm not writing it out in complete sentences because I'm trying to make this video as quick as possible so it doesn't waste much of your time, but you must write in complete sentences. It will affect your overall score if you do not. Alright, and then you want to talk about what data analysis you're going to, make this graph. How many times are you going to measure this? So how many masses are you going to use? And this, how many trials per mass? So are you going to run each trial just once? Are you going to run it 3 times? How many trials will you run? Alright, and then you should have probably a data table ready for this. Alright. After this, so that's goal. That's your first goal. So your second goal is basically if you're given distance, also known as, our final position, and the mass, what is the time? So if I have distance and mass, we can't use our first equation like we want to, right? However, what we can do, what we need to do is use the acceleration. Alright, this is going to go to 0, this is going to go 0, because initial position, we get to say it's starting, it starts from rest, so those things are 0. So really we're left with x equals 1/2 t squared. So to find t, you have to have x and a. I give you x, I don't give you a. However, in goal 1, you should have made this handy dandy graph that does explain that for every single mass, what is the acceleration? If this is my mass, this should be the acceleration. If this is my mass, this should be the acceleration. If this is my mass, this should be the acceleration. So you should be able to figure out, based on your graph, for whatever mass, what your acceleration is going to be. Then you're going to take that number and plug it in along with your distance, and solve for t. But that whole process should be explained in your own words, in complete sentences, so you can go back and recreate it. Alright, hopefully this is making a little more sense to you. Moving on to 3, or actually before that, how are you going to measure these things? 1, you're not going to measure them. It should all be in your calculations and analysis. Alright, moving on to 3. So your third goal is from these. Alright, you're explaining how it relates to Newton's second law. So basically you have to compare it to F equals ma. Well, if for F equals ma, for every mass that goes up, that means acceleration must go down. If mass goes down, that means acceleration must go up. So explain, if you have that, how will your experiment show that? So if you increase the mass, what's going to happen to your experiment? As you decrease the mass, what's going to happen to your acceleration? How will this reflect what Newton said? And how can you prove that? Hint, how can you prove it? Look at your graph. Do not just say, look at your graph. That is not a complete explanation. So think, how could a graph or a mass acceleration graph, how can that show the correlation between a lowered mass and an increased acceleration, or an increased mass and a lowered acceleration? Remember, in your own words, in complete sentences, in a paragraph. Over-explain it. Alright, hopefully this helped you a little bit, not too much, because I can't write it for you. That is your job. And I will see you tomorrow.